이프 카카오 AI 2024에 특별 연사가 참여해 주셨습니다. 엔비디아 수석부사장인 타이 맥커처가 엔비디아 AI Native Company라는 주제로 발표하겠습니다. 해외 연사인 만큼 제가 영어로 소개해 드리겠습니다. It is a great pleasure for me to welcome Mr. Ty McKercher, NVIDIA's Vice President for Worldwide Developer Relations. Ty is enhancing collaboration and optimizing NVIDIA engagement with key ISVs and accounts. We are delighted to have him among us at this conference. I hope everyone feels comfortable and enjoys this moment with our special guest, Ty. 타이 맥커처의 발표가 있겠습니다. 큰 박수 부탁드립니다.
NVIDIA is fundamentally changing the way computing is being done and how computing works. Every AI company is working with NVIDIA. The next industrial revolution has begun. But how can a company with a heritage in video games be at the forefront of the next industrial revolution? The image shown here is of our campus, our headquarter campus in Santa Clara, California. And today, we are a global leader in design and AI technology. But it wasn't always that way. In 1993, a group of passionate engineers and gamers got together with a vision to transform the way video games were being built. They invented and designed and created the graphics processing unit, the GPU. Over a period of time, as the internet was evolving, so did online gaming evolve as well. And the content distribution networks of the time didn't lend itself to a very good gaming experience. They could only stream video games. To solve this problem, NVIDIA invented the Graphics Delivery Network, GDN. We created a distributed network and we installed GeForce GPUs in a distributed environment in data centers throughout the world. Gamers that were using the GDN had a much better experience. It was much richer. The graphics was rich. It was more realistic. But importantly, because we had advanced load balancing technology and dynamic resource allocation as part of GDN, they had lower latency. In first-person games, latency matters. And if you can win the game because you have better latency, that becomes the more popular network. So our GDN attracted millions of gamers. And we had concurrency issues and latency issues. Well, as it turns out, those are the same kinds of challenges when you deliver AI models. You have a high degree of concurrency and latency. Now, one of the researchers that was using a GeForce GPU in 2012 created a GPU-based convolutional neural network and shattered the record for image classification in the ImageNet benchmark. This caused a big explosion in the deep learning world and forced the adoption and inclusion of new frameworks, deep learning frameworks like TensorFlow, PyTorch, MXNet, Theano. And they could be all available in open source, which meant you had to download and build this yourself. That's not very efficient. So what NVIDIA created was ngc.nvidia.com. We still have this available today, but rather than downloading the source and building it yourself, you could get versions that were already built and highly optimized by NVIDIA for TensorFlow and PyTorch. And also, you could get these updates on a regular basis, on a monthly basis, and you still can do that today. So ngc.nvidia.com enables enterprises to access pre-trained AI models, development tools, and infrastructure. And all the while, these are highly optimized for NVIDIA GPUs and NVIDIA DPU, our data processing units. In 2022, OpenAI introduced the world to a transformer language model called ChatGPT. And that really changed the dynamics. It forced a rapid adoption of transformer-based models and LLM models. And it challenges to be able to deliver the very best experience that you can for all these models that are evolving at a very rapid pace. And it didn't just have text-based models, but it had multimodal for video and other kinds of modalities. The challenge for that is how do you deliver a good experience and keep up with the pace of change? NVIDIA borrowed a strategy and a technique that we used in video games called Day2 titles. You see, we are able to deliver games available to play as soon as they're ready. We work with the game developers to integrate our game-ready drivers, and that allows instant access to new games. That's exactly what we're doing with the makers of different kinds of AI models, where we work with them so that on day 0, as close to the time that they release, we have a fully optimized version of that environment on our website. And for example, AI.NVIDIA.com is live now. Every one of you can go and access the environment here and experience these new models. Let's say that Meta has released Llama 2.x, and then there's a new version of Llama, the 3.x. Well, as soon as those new releases become available, we've already been working with those developers to make that available and post it on AI.NVIDIA.com. You have access to and deploy these latest models as soon as they are available. We also do full testing and support and deliver a full acceleration of these AI models on AI.NVIDIA.com. As new releases become available, we have continuous updates, and we can bring these workloads in the form of models and containers and Helm charts. Guess what AI.NVIDIA.com is built on? The GeForce Delivery Network, GDN. And we did that initially because there's a lot of concurrency and a lot of requirements for low latency for the chatbot applications, the other applications. There's biomedical-based applications and route optimization applications. There's several different types of models that are available here. And the load balancing and dynamic resource allocation that we built with our GDN network is serving AI.NVIDIA.com. Now, we know that AI models are evolving, especially in inference. And so we will also continue to evolve our GDN network as well. So what NVIDIA does is we take technology and we try to solve the problems ourselves, end to end. We built a stack that you're looking at here. I'll give you an example. We are building autonomous vehicle, end-to-end autonomous vehicle at NVIDIA. We have no purpose to sell this or compete against Tesla or other EV type, but we know this is a grand challenge. And so therefore we take this challenge on ourselves. And we develop the different AI models that have to run in very confined environments. We also we developed platform software for high performance computing to simulate the real world, the physics of the real world. We built platforms for NVIDIA AI, obviously. And then we also have a platform called NVIDIA Omniverse. It's an operating system for a digital twin. It allows us to simulate realistically, again, borrowing from the video games. We could simulate snow, or we could simulate hail, various different objects in a scene, and see how the AI models react. And that way we build confidence in our AI model in a safe environment that's all fully simulated. And that's what Omniverse allows. So we build these platforms, and then we learn a lot from this. We have a high degree of confidence these work, and then we give them to other enterprises, other partners, so they can adopt the technology. The other thing we do is we put together data center scale environments. These end-to-end problems are very large, and they require big scale computing. So we put together GPUs, CPUs, and DPUs, or data processing units, in our own data centers. And we know that these models will converge for training. We know the performance levels that will be delivered at inference time when you deploy these models. And we build a reference architecture, again, that others can borrow so that they can get to market faster. So we know that AI requires platforms, and we've built them, and we know that AI requires accelerated infrastructure. So we feel like today we're in a new industrial revolution, and companies like Kakao are building AI factories. They take data in, they refine that data, and they generate knowledge. They generate information. That's the new currency. Tokens come out of the factory. And it's not just the Kakao Talk. It could also be applied to their banking applications or their ride-sharing applications as well. In fact, we think that this has such an impact that it's going to be across all industries, a total addressable market of about 100 trillion US dollars. So we feel like we're on the cusp of a new computing platform, and it's sparking a new industrial revolution. Truly exciting times. I want to spend a minute to talk a bit about CUDA, our Compute Unified Device Architecture. It's our programming language and tool that unlocks the power of these massively parallel environments like we have for GPUs. Call your attention to the graph here. Notice that the install base for CUDA didn't start at 0. It started at an elevated place. Why is that? It's because we have millions of GeForce GPUs that are in the gamer network. So we started with a very large install base, but we made it so that you can refactor your code using CUDA to get tremendous performance gains. And so then we attracted developers. They did some interesting work to build new applications. Then end users enjoyed the benefits of those new applications. They put pressure on the OEMs and the service providers to adopt our technology, and that attracted more developers. So there's this virtuous cycle that we're enjoying with CUDA. What's interesting, and one of the reasons why CUDA is very popular, is it has a programming interface that's been consistent since 2006, compatible since 2006. And there's a layer between the programming interface and each GPU architecture. So we have new families of GPU architectures that we release on a regular cadence, like about nowadays once a year or so. And we can do completely interesting new designs for each new family of GPU. We've added capabilities for tensor cores because there's multi-levels of parallelism. We've added support for technology called NVLink and NVSwitch. We've added support for quantization and lower floating point formats to compress as much as you can out of these models so they can run in low memory environments at inference time. So we do all those innovations on each generation of the GPU, but we maintain compatibility. And the way we do that is at runtime, we determine what GPU is the application running on and do a just-in-time compilation from that programming interface so that it runs on that GPU. So that's one of the reasons why we've really had a big benefit, a growing install base, is that maintaining that compatibility, at the same time leveraging innovation. Where are we going in the future? We believe the ChatGPT moment for robotics is coming. We're going to continue to focus on AI and accelerated computing, and we're going to expand into new markets and applications. For robotics, we believe it's the culmination of everything we've been doing as a company over the years. And we've broken it into 3 computer problems. The first computer is all the AI models that you need to build to manage, to control the robots. The second computer is that and the simulation, that omniverse, where we can build digital twins and build our confidence that we know that these will perform as they should, before we then deploy them to the third computing phase, which is our embedded areas. And we have our Jetson platform as well as our Isaac platform for integration of this technology in the actual robots. So we see a really interesting world where robots are learning on the fly and also building digital humans that can augment actual humans. Okay, now I'm going to talk a bit about how we're collaborating with Kakao. We're working with the Kanana Alpha team that's building the AI models, and we're also working with Kanana X, which is working on the infrastructure team. And we're supporting Kakao's transition to an AI company. We're helping them with AI model creation. We're helping with their MLOps platform for service delivery of these models, service integration, as well as continuous innovation. The diagram that you're looking at here is our NVIDIA Inference Microservice, or a NIM. It's a way that companies can get to market faster. Again, you could try to build this stuff yourself, but we've integrated all of the latest and greatest high-performance libraries and applications and containerized this so that you can quickly adopt this. You can take this as a starting point and then adapt it to fit in your realm. Customers are using NIMs for embedding. We have an embedding and a retrieving service as part of a RAG workflow. We also are building NIMs to help with agent-based workflows as well. And we are creating blueprints, a blueprint for how to build a chatbot with a digital human that looks very, very real, or a chatbot with a biomedical, healthcare-based blueprint. And so you can take these blueprints and quickly try this out in your environment. And if you're satisfied with that, you can use it to extend it and move forward. So that's a powerful thing. We're working with Kakao to introduce NIMs where it makes sense in their environment. Some of the examples we have for collaboration, again, we're supporting the model training. We also are using our TensorRT LLM. It's a library that helps you deliver the very best inference performance. Once you've built the models, you want to deploy them, we're using these libraries. And we are using our latest GPU, the GH200 at Kakao, to validate testing for efficient inferencing. We're helping with end-to-end development, similar to what was done with OpenAI for building of ChatGPT or with Google with their Gemini models. We also see opportunities to do joint marketing with Kakao, and finally doing consulting on their data center designs. Again, borrowing on the technology and the experience that we have learned and have used ourselves, we build the reference architecture and the blueprints to try to lower the hurdle of adoption and increase the pace at which they adopt the technology. We do see a bright future between NVIDIA and Kakao as part of this collaboration. It's not just in Korea and not just at Kakao, so it's also about the broader AI ecosystem. And there's a chance, as they're building these AI services, that they can enhance even global competitiveness. The last point here is on sustainable technology development. This is really important for NVIDIA. We have a picture of the Earth. We are very conscious of how important it is to be able to do more with less. That's what the value of accelerated computing allows. We know that if you put accelerated computing in, you can get these jobs done faster with less resources. And that's a good thing for the environment. We're also looking at different interesting ways to cool these environments, and data center advances are moving at a great pace. Also part of sustainable is ethical computing for AI. It's important that we adhere to compliance. We want to make sure these are safe, and good for the environment, and good for people. And again, we feel like using our simulation environment really helps toward that goal. You can simulate the AI before you deploy it in production, therefore raising the confidence levels that this will work safely in the environments. So to summarize, we believe that we're on the cusp of a new industrial revolution. This audience here can benefit. You can use tools like ai.nvidia.com now. You can experience and try this out yourself. You can take this into your own environment. It may be a gaming environment. Try it out there. The other thing that we know is that accelerating computing helps in AI. It's mandatory. It helps. The total cost of ownership reductions is just reason enough to adopt accelerated computing. And also I talked about how we're leveraging our knowledge that we've gained from the graphics and video game technologies, which is kind of adjacent, if you will, but it really has been helpful. The work that we've done on our GDN to lower the latency and improve concurrency is a foundation that we're continuing to evolve, and as we evolve that, we'll make that available for others as well. Really appreciate you inviting NVIDIA to the conference. I hope you enjoy the rest of your day.